All right, here's another similar example where we're being asked to multiply functions. We have f and g. Once again, pay attention to the closed dot, right? The closed dot that represents product. So we have a couple of different polynomials. We have a trinomial for x, f of x, and then a binomial for g of x. So very similar process. The only difference is that we have slightly larger polynomials. All right, so what do we need to do? Well, if we are going to multiply f of x with g of x, we need to set it up first as x squared minus 4x plus 3, and we will be multiplying that times our g of x function, which is the binomial negative x plus 4. All right, now since we have a trinomial and a binomial, foiling this out, which is a common method, can get a little bit messy. So there's an alternative method, which is maybe sometimes called the box method or rectangle method, where we set it up using a rectangle. So I'm going to set up a rectangle with 3 columns, 1 column for each of the terms. So x squared, negative 4x, and positive 3. Each one of them gets their own column. And then if I go across, I want to cut this into 2 rows because I have 2 terms in my second polynomial. So the negative x and the positive 4, they get their own row. And then what we do is we just multiply the terms and then we put them inside of that box. And what it does is it just helps us when it comes to organization. So what we'll do here is we'll multiply the x squared with the negative x. That will give us negative x to the third. Then we'll multiply our negative 4x times negative x again. That gives us a positive 4x squared. And then we multiply the positive 3 with the negative x. That would be a negative 3x. All right, then we move on to the next row. So now we're going to do the same. We're going to multiply the negative x squared, but this time with the 4, right, the constant. So that gives us a positive 4x squared. Then we'll multiply negative 4x with a positive 4. That'll give us negative 16x. And then lastly, we'll multiply the 2 constants. 3 times 4, that'll give us a positive 12. All right, so it's nice and neatly organized. The only thing we have to do now is then combine those like terms. So we'll have some like terms. Typically, like terms show up across diagonals. So say, for example, I were to go across this main diagonal in the first box. Well, there's no other x to the third term to combine with. So then I would just bring that down as a negative x to the third. All right. Then I go across the next diagonal, which would be the positive 4x squared with another positive 4x squared. Those are like terms, so we get to combine those, add them up. We get positive 8x squared. All right, next diagonal, we have the negative 3x with a negative 16x. Those are also like terms. They can combine to give us negative 19x. And then the last term, the 12, we go across that diagonal. There is no other like term. There is no other constant. So we end up with just plus 12. So the product, f times g of x, is this new polynomial, negative x to the third plus 8x squared minus 19x plus 12.